Hi everyone. So today we're going to be on page 31, and hopefully you're familiar with our parametric equations at this point. What we're going to do is kind of look at what happens when we mix in our trig equations from last semester. Here we have x equals a cosine of t, y is equal to a sine of t. Now, it's going to be kind of hard to quickly see how we relate these two, but remember that we have the Pythagorean identity. It says to use it right here. The Pythagorean identity just tells us that we have cosine squared, in this case t, plus sine squared of t equals 1. So somehow we're going to have to get our cosine of t and sine of t by itself. So let's first take our x equals a cosine of t and solve for cosine of t. And all that's going to involve in this case is dividing by a. The a's cancel out on the right side. We have cosine of t is equal to x divided by a. And then we're going to do the same thing for our y's. We have y is equal to a sine of t. We'll divide both sides by a. And a's cancel out on the right side, leaving us with sine of t is equal to y divided by a. So when we go to plug this back into the above Pythagorean identity, we're going to have x divided by a squared plus y divided by a squared equals 1. Well, we're going to distribute the exponents. We get x squared over a squared plus y squared over a squared equals 1. Now, this kind of looks like our ellipse equation, but instead of an a squared and a b squared, we just have a squared. In other words, a and b are the same. So if we draw a quick little sketch of what would happen in this case, if my a and b are the same, then both the vertices and co-vertices are the same. This is basically just a circle. Now, remember when we were dealing with our sines and cosines from last semester? We typically restricted our angle to be from 0 to 2 pi. Now, in this case, our theta is going to equal t. So we're going to restrict our t from 0 to 2 pi in order to just draw a circle. Now, if I go back to my little diagram up here, our equation is just basically me drawing a circle. As t increases, we go further around the circle. If I instead restricted t to be 0 to pi, well, that's just me going halfway around the circle. And if we had our t to be even larger than 2 pi, so let's say 0 to 4 pi, that would be me going around the circle once, twice. Okay? Now, over here, it's going to be basically the same idea. Instead of using t, we have theta, and here our x is equal to 3 cosine theta, our y is 4 sine theta. Neither of the two equations have the same a value. All right, so we're going to do just like we did before. We have x is equal to 3 cosine theta. We're going to divide both sides by 3. We get cosine theta equals x divided by 3. We're going to have our y equals 4 sine theta. We'll divide both sides by 4. We get sine of theta equals y divided by 4. So using the Pythagorean identity from the last page, or last example, we're going to have x divided by 3 squared plus y divided by 4 squared is equal to 1. And then we'll distribute those exponents, giving us x squared divided by 9 plus y squared divided by 16 equals 1. Here we have an ellipse equation, and we're going to have our a equals 4, our b equals 3. Remember that our a is always bigger than b. And just like before, we're going to restrict our theta to be from 0 to 2 pi. This way we go fully around, in this case, our ellipse. So looking at our equation, we have x squared and y squared, telling us that we're going to be centered on the origin. We have this a equals 4 underneath our y, so I'm going to go 4 up, make a point there, 4 down, make another point. Those are our vertices. And then I'll go using our b equals 3, 3 to the left, 3 to the right, whoops, right and left, whatever. And those are our co-vertices. We'll just connect all these points together the best we can. And there's our rough ellipse. So here we have a slightly more complex equation. I want you to take a few seconds and, using the techniques from the last two problems, try this yourself. Try to solve for cosine of t and sine of t, and then rewrite it as a new equation using the Pythagorean identity. So here, it's not as simple as dividing the coefficient from our cosine and sine. With those numbers out front, we have to move them to the other side to get our cosine by itself. So we subtracted the 1 from both sides, and we get x minus 1 equals cosine of t. And then on the y, we subtracted 5. We got y minus 5 is equal to negative 2 sine of t, and divided both sides by negative 2. And that left us with sine of t equals negative y minus 5 over 2. And what you should see when you plug it into that Pythagorean identity is we're left with x minus 1 squared plus y minus 5 squared over 4. Now that minus sign that was out front of our sign, that just disappears. When you square something, a negative times a negative becomes a positive. So we don't even have to worry about that. And that's it. So with the trig functions, it might look intimidating, but it's really not that bad, as long as you use the Pythagorean identity. Hope you'll have a good one.